Alright, so we look at tangents and normals to a circle. So what is a tangent? A tangent to a circle is a line which touches the circle at only one point and makes 90 degrees with the radius of the circle. And how about the normal? The normal to a circle is a straight line drawn at 90 degrees to the tangent at the point where the tangent touches the circle. So the normal is also perpendicular to the tangent. So that's how we define the normal. But now let's focus on the tangent in this case. So now this is a circle with center CAB, and then as we've said, the tangent is a line that touches the circle at only one point. So that line up there represents the tangent. So it touches the circle at this point right there. So we're going to label that point as point A. We shall have the coordinates x0 and y0. So what we can see is that when we connect that point to the radius of the circle and then connect it to the center, we shall actually see that it makes an angle of 90 degrees at that point. So a tangent is always perpendicular to the radius of the circle. Now we can also see that the length of the radius is always the perpendicular distance of the tangent to the circle. If the point at which the tangent touches the circle is given, then the radius is simply equal to the distance between the point where the tangent touches the circle and the center of the circle, as you can see. Okay, let's look at obtaining the equation of a tangent to a circle at a given point. So how do we do that? So looking at the sketch given, if the tangent touches the circle at the point A, x0, y0, the following steps are taken to find the tangent to the circle. So first, we obtain the coordinates of the center of the circle. Next, we find the gradient of the line SC. This shall be the gradient of the radius of the circle, and then we shall name it M1. And then since the line SC and the tangent are perpendicular, you can then obtain the gradient of the tangent line using the condition for perpendicular lines. So that means that gradient of SC times gradient of tangent shall be equal to -1. So we'll have M1 times M2 being equal to -1. And then from this formula, we can see that the gradient of the tangent shall now be equal to, and now from this formula, we can see that the gradient of the tangent M2 shall be equal to -1 over M1. Then lastly, we're going to assume a point PXY on the tangent and then use PXY and AX0, Y0 and find the required equation of the tangent from this formula right here. Alright, so these are the steps we shall take, but this will make more sense as we look at different examples. So question 1, given a circle 2x squared plus 2y squared minus 8x minus 5y minus 1 is equal to 0, find the equation of the tangent to the circle at the point 1, -1. So first of all, I encourage you to sketch this to actually have a better interpretation. So that's the tangent touching the circle at the point A1, -1. And then this is the radius R. Then we can set it makes an angle of 90 degrees with the radius of the circle. Alright, so first of all, this is the equation of the circle. So we're going to use it to find the center and radius of the circle. So now first of all, we can see that first of all, we have to divide everything by 2 so that we have the coefficients 1 in front of x squared and y squared. So this shall become x squared plus y squared minus 4x minus 5 over 2y minus a half being equal to 0. So now when we compare this with the Cartesian equation of a circle, we can see that 2g shall be equal to -4, which shall mean that g is equal to -2. Then you can also say that 2f shall be equal to -5 over 2, which shall mean that f is -5 over 4. So therefore, the center of the circle, which is given as -g, -f shall be 2, 5 over 4. Now that we know that, we can now find the gradient M1, which is the gradient of the radius. So now that we know that the point A is the point at which the tangent touches the circles, and we know that C is the point at the center of the circle, we can use these 2 points to find the gradient of the radius. So therefore, the gradient of the radius shall be equal to, so we're going to have it as -1, so we're going to subtract the y values. So -1 minus 5 over 4 over 1 minus 2, which shall give me -9 over 4 divided by -1, which the answer shall be 9 over 4 as the gradient of the radius. So now that we know that, we can now find the gradient of the tangent M2. So we know that since the tangent is perpendicular to the radius, we can actually find the gradient of the tangent from the formula M1 times M2 is equal to -1. So we shall have it this way. So m2 shall be equal to negative 4 over 9. So that's what you get when you divide negative 1 by 9 over 4. So this is what you get. So the equation of the tangent at the point 1, negative 1 can now be found. So now we shall use the point at which the tangent touches the circle, which is the point A, 1, negative 1, and find the equation of the tangent. So the formula shall be y minus negative 1 over x minus 1 being equal to the gradient of the tangent, of which we shall have 9y plus 9 being equal to negative 4x plus 4. And eventually we will have y being equal to negative 4 over 9x minus 5 over 9. And this is the equation of the tangent. So the equation of the tangent to the circle at the point 1, negative 1 is y is equal to negative 4 over 9x minus 5 over 9. Question 2. Find the equation of the tangent to the circle 4x squared plus 4y squared minus 12x plus 24y minus 55 is equal to 0 at the point negative 3 over 2, 1. Alright, so let's sketch this again. So now that's the center of the circle. So that's the point where the tangent touches the circle. So now that point is negative 3 over 2, 1. And then r is the radius, and we can say the radius is perpendicular to the tangent. Now this is the equation of the circle given. So first of all, we need the coefficients 1 on the x squared and the y squared. So we divide all by 4, and we shall have x squared plus y squared minus 3x minus 6y minus 55 over 2 is equal to 0. So now comparing this to the Cartesian equation of a circle, we can find the center coordinates. So now we can see that 2g shall be equal to negative 3. So that means that g shall be equal to negative 3 over 2. You can also say that 2f shall be equal to negative 6, which will mean that f shall be equal to negative 3. So now that we know that, we can now see that the center of the circle, which is negative g, negative f, shall be 3 over 2, 3. And this shall be the center of the circle. So now that we know that, we can now find the gradient of the radius. Therefore, the gradient PC, which is the gradient of the radius m1, shall be found from these two coordinates. So now to note point C, and we know that the coordinates of the center are given that way, we can now find the gradient m1 of the radius as this. So we'll have 1 minus 3 over negative 3 over 2 minus 3 over 2. So I'll have it as negative 2 over negative 6 over 2, which shall be equal to negative 2 over negative 3, which is equal to 2 over 3. So this is the gradient of the radius. Now the gradient of the tangent m2 can now be found. Now we know that the tangent is perpendicular to the radius. So it means that to find the gradient of the tangent, m1 times m2 shall be equal to negative 1. So now m2 shall be equal to negative 1 over 2 over 3, which shall be negative 3 over 2. So that is the gradient of the tangent m2. So now to know that the gradient of the tangent is that, now we just need to remember that the point where the gradient touches the point where the tangent touches the circle is the point P, negative 3 over 2. So we shall use that point to find the equation of the tangent. So we shall have it as 1 minus 1 over x minus negative 3 over 2, which shall be equal to the gradient of the tangent, which is negative 3 over 2. So this is what we'll have. So we'll have 2y minus 2 being equal to negative 3x minus 9 over 2. Of which now when we solve this further, I'll have the answer as being equal to negative 3 over 2x minus 5 over 2. And that shall be the equation of the tangent. Question 3. Find the equation of the tangent through a point P34 on the circle x squared plus y squared is equal to 25. So this is what we have. So that's the center of the circle. Then this is the point where the tangent touches the circle, the point P34. And then r is the radius. And we can say the radius is perpendicular to the tangent. So now the equation of the circle has been given as x squared plus y squared is equal to 25. So we can arrange it this way. So now if we compare this with the Cartesian equation of the circle, we can see that 2g shall be equal to 0, of which g shall be equal to 0. Then we can also say that 2f shall be equal to 0, of which f shall be equal to 0. So it means that the center of the circle shall be the points 0, 0. Alright, so now we know that we can actually find the gradient PC, or the gradient of the radius. So now we have the point at which the tangent touches the circle, and we have the center of the circle. So now let's find the gradient of the radius. So we shall have it as 4 minus 0 over 3 minus 0, which shall be 4 over 3. So now that we know that the gradient of the radius is given that way, we can now find the gradient of the tangent m2. So the gradient of the tangent shall be found as m2 being equal to negative 1 divided by 4 over 3, of which m2 shall be equal to negative 3 over 4. So now that we know that the equation of the tangent at the point P3, 4, the point where that tangent touches the circle, shall be y minus 4 over x minus 3 being equal to the gradient of the tangent, which is negative 3 over 4. So when you cross multiply, we'll have 4y minus 16 being equal to negative 3x plus 9, of which when we simplify this further, y shall be equal to negative 3 over 4x plus 25 over 4, and this shall be the equation of the tangent at the point P3, 4. So therefore the equation of the tangent to the circle is y is equal to negative 3 over 4x plus 25 over 4. Okay, so now next we move to another example, but in this unique example is we're going to find the equation of the tangent to the circle, but we're going to be using a different method this time. So this time we're going to use the method of differentiation to see if it will actually also work in this case, but it actually will. Alright, so now this is the circle, and then that is the center. Then we've said that the tangent touches the circle at the point 1, 0. So we've called that point P. And then the radius is R. Alright, so the other method that we can use is we can actually differentiate this. So when I differentiate this, I can actually say that I differentiate it the way I differentiate implicit functions in differentiation. Then that's what I'll have. Then I'll collect terms that have dy dx together, and then group them together, take the others to the other side. Then here I can factorize out the dy dx on the left hand side, and I'll have 2y minus 1, make dy dx a subject, and shall be equal to 5 minus 2x over 2y minus 1. Alright, then at the point 1, 0, I'm actually going to plug in for the values of x, and then this is what I'll have for the values of x. So where there is x, I put 1, and where there is y, I put 0. So that's what I'll have. So when I solve this, I'll have 3 over negative 1, of which dy dx shall be equal to negative 3. So what happens is this value of dy dx shall be the gradient of the tangent. So what we get as dy dx is given as the gradient of the tangent. Alright, so now to find the equation of the tangent at the point P1, 0, we shall just use these different values. So we shall equate these to negative 3 as the gradient. So the points we're going to be is 1, 0, so that's why you see y minus 0 over x minus 1 being equal to negative 3. And then y shall be equal to negative 3x plus c. So I don't know what feels easier for you, but this could be another method that you can use to find the equation of the tangent. So the equation of the tangent shall be y is equal to negative 3x plus 3, and that is the answer. So the equation of the tangent to the circle at the point 1, 0 is y is equal to negative 3x plus 3. Question 5. Find the equation of the tangent and normal to the circle x squared plus y squared plus 2x minus 8y plus 4 is equal to 0 at the point 2, 2. So in this case, they've asked us for both the equation of the tangent and that of the normal. Alright, so we've sketched the circle, so that's the center. So we've said that the tangent touches the circle at the point 2, 2. So that's why we have it there. And then that's the radius. Alright, so again, this is the equation of the circle. So we're again going to use the method of differentiation in this case. But you should note that the other first method would also have worked, but I've just chosen to use differentiation. So now I differentiate both sides using the knowledge of implicit differentiation. Then this is what I'll have. Then collect the values I have dy dx together, factorize out dy dx, and dy dx shall be equal to negative 2x minus 2 over 2y minus 8. Then we'll look for the value at the point 2, 2. So when you look at the point 2, 2, plug in. So where there is x, you put 2, and where there is y, you put 2. And then dy dx shall be equal to it shall actually be equal to negative 6 over negative 4, which is actually the same as 3 over 2. So that shall be the gradient of the tangent m1. Now we can look for the equation of the tangent at that point 2, 2, of which we will have it as y minus 2 over x minus 2 being equal to 3 over 2. Then we shall have it as 2y being equal to 3x minus 2, of which if I make y the subject, y shall be equal to 3 over 2x minus 2 over 2, which is the same as 3 over 2x minus 1. So therefore the equation of the tangent to the circle at the point 2, 2 is y is equal to 3 over 2x minus 1. So now that we know that, we've also been told to find the equation of the normal. So first of all, to find the gradient of the normal m2, remember that a normal is perpendicular to the tangent. So that means that to get the gradient of the normal, we'll have m1 times m2 being equal to negative 1, of which m2 shall be equal to negative 1 over m1. Now we can see that m2 shall be equal to negative 2 over 3. So that shall be the gradient of the normal. So now that we know that the gradient of the normal is negative 2 over 3, we can find the equation of the normal at the point 2, 2. So it shall be equal to that. So now we shall have y being equal to negative 2 over 3x plus 10 over 3. So therefore the equation of the normal to the circle at the point 2, 2 is y is equal to negative 2 over 3x plus 10 over 3, and that is the answer. Alright, so we move on to question number 6, and this question is a question from UNEB 2008, and this was question number 9. So we're being told that a circle cuts the y-axis at 2 points A and B. Then we're being told that it also touches the x-axis at a distance 4 units from the origin. The distance AB is 6 units, and we're being told that A is the point 0, 1. Find the part A equation of the circle, part B equations to the tangents to the circle at A and B. So when you're given such a question, I encourage you to first sketch it. So we're going to actually sketch it on x and y axes. So basically that is the circle that we have. So being told it cuts the y axis at 2 points, so that's why we have it that way. Then we've been told that it also touches the x axis, so that's why we have it that way. Then we've also been told that point A is the point 0, 1, and then we've also been told that the distance AB is 6 units. So that means that moving from A to B, it's a distance of 6 units. So what does that mean? Since we're on the y-axis, it actually means that the values of x remain at 0. But since we are moving from here to here, it actually means that we're going to add a 6 to this 1 to actually get the coordinates of point B. So point B shall be 0, 7. Alright, and then next, we've been told that there shall be equations of the tangents to the circle at A and B. So that means we can draw tangents at that point, and that is a tangent at point A and the other one is a tangent at point B. So we can see that they actually make an angle of 90 degrees with the radius towards the center. Then we've also been told that it also touches the x-axis at a distance 4 units from the origin. So that means we have a point right there. So that's the point 0, 4. And then that is the center AB. So we're going to call that point where it touches the x-axis, we're going to call that point D, and we're going to call that, and the coordinates there are points 4, 0. So this is what we have now. Alright, so now we are going to have to first solve in a way and get the values of the coordinates of the center. So right now we don't know what the coordinates of the center are, and why is that? It's because it cuts through here and it also touches here, so it's not clear to know what the coordinates of the center are. So we're actually going to find it, but good enough we can, because we have 3 different points given. Alright, so let's look at it this way. So at point A, this is the equation of a circle. So now for me to solve it in the way that I actually want, I'm actually going to convert this. So I prefer to actually use this as points A and B. What we know is point G represents negative A, and of course A also represents negative B. So we're going to substitute them with points A and B. So now I have a negative A for where I have G, and I also have a negative B for where I have F, plus C is equal to 0. Alright, so now I can see that at this point x is 0 and y is 1. So that's why we have it this way. So when I simplify further, I'll have 1 minus 2b plus c being equal to 0, of which I'll have the equation 1 as being equal to negative 2b plus c being equal to negative 1. Alright, at point B 0, 7, this is the equation. So I'm also going to put it in terms of A and B. It's what I prefer. But remember, this will also work out if you leave it in terms of G and F. It will still okay. Of which at the end you have your centers being negative G, comma negative F. It's just my preference to use negative A and negative B for G and F. So now when I substitute for x and y, this is what I have. Simplify this further and I have negative 14b plus c being equal to negative 49, and that shall be equation 2. Then at the point D, 40, this is what I'll have. So substituting the values, and I'll have 16 minus 8a plus c being equal to 0, of which the final equation shall be negative 8a plus c being equal to negative 16, and that shall be equation 3. So now to find the values of a, b, and c, I can see that the first thing I can do is I can subtract equation 2 from equation 1, and that means the c's will cancel and I'll be left with this value, I'll be left with 12b being equal to 48. And then I shall see that b shall be equal to 48 over 12, of which b shall be equal to 4. Now that I know the value of b, I can substitute for b into equation 2, of which I'll have it as this. So c shall be equal to 7. So now that I know the value of c being equal to 7, I can now find the value of a by substituting for the value of c in equation 3. So in equation 3, I will have negative 8a being equal to negative 23, of which a shall be equal to negative 23 over 8. Now I can find the radius of the circle. Now where radius of the circle, we remember the formula is a squared plus b squared minus c. Now we shall see that r squared shall be equal to bracket negative 23 over 8 squared plus 4 squared minus 7, of which I'll have 529 over 64 plus 16 minus 7. And then if I add up all these, I'll have 1105 over 64. Now r shall be equal to the square root of 1105 over 64, of which I'll have root of 1105 over 8 units. Alright, so now I can find the equation of the circle. So now let's plug all these into the general equation of a circle, and I'll have it this way. So when I expand this, x plus, now the reason here I have a plus is because remember this was a negative 23 over 8. So plug that in and then expand, and I'll have x squared plus 23 over 4x plus 529 over 64. And then expand this and I'll have y squared minus 8y plus 16. Then when I square this, I'll have 1105 over 64. Alright, so when I rearrange the terms and actually bring the value of 1105 over 64 here, I can actually say that when I subtract everything, I'll be left with 16 minus 9, which shall give me 7. So therefore, the equation of the circle shall be x squared plus y squared plus 23 over 4x minus 8y plus 7 is equal to 0. And that's the equation of the circle. Right, so in part B, we're being told to find the equations to the tangents to the circle at A and B. So we need to know the equation of this tangent and the equation to this tangent also. Alright, so for part B, so this is the general equation of a circle that we actually have. So first of all, we need to know the gradient of the tangent. So we're going to do that by differentiating. So now when I differentiate both, now this I can differentiate implicitly, and this is what I'll have. So group the values that have dy dx together, take the other values to the other side of the equal sign, make dy dx the subject, and dy dx shall be equal to negative 2x minus 23 over 8y minus 32. Now at the point A, 0, 1, let's look at the tangent at that point. dy dx shall be equal to negative 2 times 0 minus 23 over 8 times 1 minus 32. So I'll have negative 23 over negative 24, of which the gradient at that point shall be 23 over 24. So that's the gradient of the tangent at point A. So now I can find the equation of the tangent. So the equation of the tangent at point A, which is 0, 1, shall be y minus 1 over x minus 0 being equal to 23 over 24. So cross multiply, and I'll have y being equal to 23 over 24x plus 1. And that is the equation of the tangent at the point A. How about at the point B? So now I'm also going to plug in to find the gradient of the tangent at that point B. So plug it into dy dx, and dy dx shall be negative 23 over 24. So that is the gradient of the tangent at the point B. So now let's find the equation of the tangent at that point B, which is 0, 7. So now I have y minus 7 over x minus 0 being equal to negative 23 over 24. So we shall see that y shall be equal to negative 23 over 24x plus 7, and that is the equation of the tangent at point B. So therefore, the equation of the tangent to the circle at A is y is equal to 23 over 24x plus 1, and at B is y is equal to negative 23 over 24x plus 7, and those are the answers they wanted. Alright, so next let's look at how to find the length of the tangent from a given external point to a circle. So now the length of the tangent AB drawn from a point B x1 y1 to the circle x squared plus y squared plus 2gx plus 2fy plus c is equal to 0 is given by this. So let's look at what we mean. So now we're being told that there is an external point to the circle. So that external point is the point B. So the tangent comes from that point and touches the circle at point A. And then we can see that the radius of the circle is r, and then we are going to connect point C, the center, to the point B. Alright, so in this case, what we're trying to solve is to always find this distance. We're trying to find the length of the tangent given a certain point B. How do we usually do that? As you can see, since the radius makes an angle of 90 degrees with the tangent to the circle, so we can actually already see that this actually forms a right angled triangle, of which we can find the points AB using Pythagoras theorem. So from Pythagoras theorem, we can already see that AB squared plus AC squared is equal to CB squared, of which CB represents the hypotenuse to that right angled triangle. So now we can see that AC is represented by radius, so we can actually plug in the radius at that point. So we'll have AB squared plus R squared being equal to CB squared, of which I can actually make AB squared the subject, since AB squared is what I'm looking for, and you can see that AB squared shall be root of CB squared minus R squared. Alright, so whenever we want to find the value of CB, we can actually get it when we know the coordinates of the center and the coordinates of the point where the tangent is being drawn from. So we get CB from x1 minus a squared plus y1 minus b squared. Now this is useful when the point where the tangent touches the circle A is known. Let's look at some examples. So I've been told to find the length of the tangent from point 57 to the circle x squared plus y squared minus 4x minus 6y plus 9 is equal to 0. So let's sketch this. So now the point is point B. Let's call it point B, and we give it the coordinates 5, 7. It touches the circle at point A. The radius is R, and then that is the line CB. Alright, so the first step shall always be first find the coordinates of the center of the circle. How are we going to do that? We're going to compare with the general Cartesian equation of a circle. So when you compare, we shall see that 2g shall be equal to negative 4, of which g shall be equal to negative 2. We can also say that 2f shall be equal to negative 6, which shall mean that f shall be equal to negative 3. Now the center of the circle, which is negative g, negative f, shall be 2, 3. So now to know that, we can also find the radius of the circle from this formula. So the radius shall be equal to root of 4, which shall be 2 units. So now that we know that, we can now solve from Pythagoras theorem, now that we know the coordinates of the center. So now AB squared plus AC squared shall be equal to CB squared. Now we remember that AC is represented by radius. Now we can see that radius is R, so we shall have that as 2 squared, of which 2 squared is 4. So now that we know that, we can actually now first solve for CB. So remember how we found CB. So we shall have the coordinates of the point that was given minus the coordinates of the center from this formula. So we shall have 5 minus 2 squared plus 7 minus 3 squared, of which CB shall be equal to root of 25, of which CB shall be 5 units. So now to know the coordinates, we know the value of CB. AB squared shall now be equal to this. So now we remember that CB has to be squared. So now CB squared shall be 25. Of which, when I make AB squared the subject, AB squared shall be equal to 25 minus 4, of which AB shall be equal to root of 21 units. So that is the length of the tangent to the circle. So the length of the tangent to the circle is root of 21 units. Part 2. Find the length of the tangent from negative 2, 3 to the circle x squared plus y squared plus 6x plus 10y minus 2 is equal to 0. So now we are going to place the point. That is the point. We're going to call it point B, then touching the circle. So again, we're going to have to first find the center of the circle and the radius. So now comparing this equation of the circle with the general Cartesian equation of a circle, we can see that 2g shall be equal to 6, of which g shall be 3. Then 2f shall be equal to 10, of which f means f is 5. So the center of the circle, which is negative g, negative f, shall be negative 3, negative 5. That means the radius of the circle can be found from this formula, of which I'll have root of 36, of which root of 36 shall be 6 units. So now I can solve from Pythagoras theorem. So AB squared plus AC squared is equal to CB squared. But remember that AC squared is the radius. So we have 6 squared, which is 36. So now let's solve for CB. So CB can be found from this formula. So now I have it as negative 2 minus negative 3 squared plus 3 minus negative 5 squared, which shall be give me this. So now this eventually shall be negative 2 plus 3 squared, and this shall give me 3 plus 5 squared, which shall be 8, and then this will give me 1. So I'll have root of 65 units. So plug that back in and I'll have it this way. So now when we square that value, when we square this value here, I'll have 65. Now we can say that AB squared shall be 65 minus 36, which shall be 29. Now AB is going to be the square root of what we find, which shall be root of 29 units. So therefore the length of the tangent is root of 29 units, and that is the answer. Alright, let's move on to question 3. So question 3, we're being told that the find value of k if the length from the point 1, 1 to the circle x squared plus y squared minus 4x minus 6y plus k is 0 is 2 units. So now we know the length of the tangent at the very beginning. So that is the point we're connecting to the circle, and then this is what we'll now have. So you can see that AB is now known, so AB is 2 units. So that means we just have to solve for k. Now before we do that, we shall do the usual thing. We shall first find the center of the circle and the radius. So now comparing this to the Cartesian equation of the circle, we can already see that this is what we'll have. So you can say that 2g is equal to negative 4, of which g shall be equal to negative 2. Then also you can say that 2f is negative 6, which shall mean that f is negative 3. So the center of the circle, which is negative g negative f, shall be 2 and 3. Now when we solve for radius, radius shall be root of g squared plus f squared minus c. So that means we'll have it this way. But remember that c is represented now as k. So now when we solve this, we'll be left with root of 13 minus k. So that shall be our radius. Now from Pythagoras theorem, we shall see that ab squared plus ac squared is equal to cb squared. Now remember that radius is ac is r squared. Now we're going to plug in what we found. So we have root of 13 minus k squared, of which this shall be left as 13 minus k, and then here AB was known, so AB is 2, so we'll have 2 squared, which is 4. So now we'll have it this way. So remember when we're solving for CB, CB is x minus a squared plus y minus b squared in a root. So this is what we'll have, of which CB shall be equal to root of 5 units. So plug that in and this is what we'll have. Now root of 5 squared shall be 5. So now we'll have this. 4 plus 13 is 17. So 17 minus k shall be equal to 5. Make k the subject actually by taking k to this side. So we're going to take k to the right hand side of the equal sign and bring this 5 to the left hand side. So and then we shall see that k shall actually be equal to 12, and that is the value of k. Alright, so next we look at proving that a line or tangent touches a circle. Alright, so if ay is equal to mx plus c is the line, and x squared plus y squared is equal to a squared is a circle, substituting for y in equation of the circle gives this. So this is what happens when I actually substitute for y. So when I expand this further, I'll have m squared x squared plus 2mxc plus c squared is equal to a squared. So let's actually make this look more like a quadratic equation. That means that those values that have x squared are grouped together, those values that only have x are grouped together, and those that don't are grouped together. So when I do that, this is what I end up having. So this is more of a quadratic form of expressing it. So now when we look at this, if we're to consider this to be a quadratic equation where a shall be equal to 1 plus m squared, b is this 2mc, and c is equal to this c squared minus a squared. Now remember, these a, b, and c here are what we represent as the coefficients of a quadratic equation. So that's what this a, b, and c here mean. So if we focus on them as coefficients of a quadratic equation, we can see that if b squared minus 4ac is greater than 0, the line is a secant to the circle. A secant line is a line that goes through the circle and intersects the circle at 2 points. So we can also say that that line is a chord to the circle. So these are the different terms that you actually know when a line actually cuts or intersects the circle at 2 points. So this is what we actually have right now. So that means that if you have this value, if you plug in your values and then you have this value being greater than 0, it means that that line is a secant line, or it cuts through the circle. Then for condition 2, if b squared minus 4ac is equal to 0, this simply means that the line touches the circle, and therefore the line is the tangent to the circle. So we've just been covering what it means for a line to be a tangent to the circle, and that's how we prove that a line is a tangent to a circle. And then in 3, if b squared minus 4ac is less than 0, it means that the line doesn't meet the circle. So therefore the line neither touches nor cuts the circle. So this is one way that you can actually show it. Let's look at some examples. So I've been told to prove that the line y is equal to x plus 3 neither cuts nor touches the circle x squared plus y squared minus 6x plus 8y minus 7 is equal to 0. So this is the line that we've been given. So now the first step shall be to substitute for y into the equation of the circle. So where there is y, we shall actually put the values x plus 3. So now when we expand these, I'll have x squared plus 6x plus 9. And then right here, this shall give me 8x plus 24. And then now, when I group all the terms and add them and simplify, I'll have 2x squared plus 8x plus 26 is equal to 0. So now when I look at this, I shall now look at the coefficients. So now we remember that for the line to neither cut or touch the circle, b squared minus 4ac must be less than 0. So as you can see, the coefficient b is 8, and then the coefficient a is 2, and the coefficient c is this 26. So plug that in and I'll have this. So when I simplify this, the value that I get is negative 144. And negative 144 is a value less than 0. So since that is true, it means that therefore the line is not a tangent to the circle and neither touches nor cuts the circle. So that's how we prove that that line neither cuts nor touches the circle. Question 2. Prove that the line y is equal to 3x plus 1 is a tangent to the circle x squared plus y squared minus 14x minus 4y plus 13 is equal to 0. Alright, so this is the equation of the line. Now we can actually see that we can actually plug in for y into the equation of the circle. So this is what I have. So when I expand this and simplify, I'll be left with 10x squared minus 20x plus 10 being equal to 0. So I can see that for the line to be a tangent to the circle, we remember that b squared minus 4ac should be equal to 0. So now we can see that the coefficient for b is negative 20, the coefficient for a is 10, and then the coefficient for c is this 10. So plug those in and I'll have 400 minus 400, which is actually equal to 0. So therefore this line is a tangent to the circle. Question 3. Prove that the line y is equal to x plus 4 intersects the circle x squared plus y squared plus 8x plus 2y minus 84 is equal to 0. So now this is the line. So substitute for y in the equation of the circle, and this is what I'll have. So simplify further and I'll be left with 2x squared plus 18x minus 60 is equal to 0. So we've said that for the line to intersect the circle, b squared minus 4ac must be greater than 0. So now substitute those values in and I'll have 804, and this value is surely greater than 0. So therefore the line intersects the circle. Question 4. For what values of c will the line y is equal to 2x plus c be a tangent to the circle x squared plus y squared is equal to 25? So now in this case we need to actually find the values of c that actually show or make this line be a tangent to the circle. So we're going to follow the same steps. So this is the line. So first of all, we're going to substitute for y into the equation of the circle, and then when I expand further, I'll have x squared plus 4x squared plus 4xc plus c squared is equal to 5. So now separate the different terms that have x squared, those that have x to the power 1 and those that don't. So when I group them, I'll have it this way. So this is what I have finally. So now that I have that, I can now compare. So remember that for the line to be a tangent to the circle, this condition must be satisfied. So when I plug it in, I can see that for b, the coefficient b is 4c, the coefficient a is 5, and then the coefficient for c is c squared minus 5. So plug those in and this is what I'll have. So simplify this further and I'll have negative 4c squared plus 100 being equal to 0. So now negative 4c squared shall be equal to negative 100, of which c squared shall be equal to 25. So now when I find the value of c, c is either positive or negative 5. So therefore either c should be equal to 5 or c should be equal to negative 5 for this line to be a tangent to the circle. Question 6. For what values of alpha does the line 3x plus 4y is equal to alpha touch the circle? 3x squared plus y squared minus 10x is equal to 0. So now here, this is the equation of the line that we've been given. So first of all, I'm going to make y the subject, and y shall be equal to alpha minus 3x over 4. So substitute for y into the equation of the circle, and this is what I'll have. So simplify this further, and then I'll have 16x squared plus alpha minus 3x squared minus 160x being equal to 0. So now expand that value here, and I'll have alpha squared minus 6 alpha x plus 9x squared. So now collect like terms, and I'll have 25x squared minus 6 alpha x minus 160x plus alpha squared. So now group all the terms that actually have the same coefficients. So now I can see that I can actually group these terms together because they all have the coefficient. I mean, they all have x to the power 1, and these have x to the power squared, and these ones don't have x at all. I mean, this have x to the power 0 actually, which is actually 1. So now when I actually look at this, now being told for what values does this prove that this line touch the circle. So that means that we must prove that line, we must find values of alpha that show that that line is the tangent to the circle. So the values of alpha that make that line a tangent to a circle. So now remember that for a line to be a tangent to the circle, b squared minus 4ac should be equal to 0. So now plug in the values of b. So the coefficients for b shall be negative 6 alpha minus 160. Then for a is 25, for c is alpha squared. So expand this, and this is what I have. I have 36 alpha squared plus 1920 alpha plus 25,600 minus 100 alpha squared is equal to 0. So group values together, and I'll have this quadratic equation, of which when I solve this quadratically, I'll have alpha as either being equal to negative 10 or alpha being equal to 40, and those are the values of alpha that will make this line a tangent to the circle. The next question is a question from UNEB 2006, and this was question 13b. So I'm being told that the line x plus y is equal to c is a tangent to the circle x squared plus y squared minus 4y plus 2 is equal to 0. Find the coordinates of the points of the contact of the tangent for each value of c. So this is the same thing. So first of all, I'm going to make y the subject. Y shall be equal to c minus x, of which when I substitute for y into the equation of the circle, this is what I'll have. So when I expand each of the values, this is what I have. And then I'm going to simplify further and group values that have x squared, and then group those values that have x to the power 1, and group those values that don't have x at all. So this is what I'll have. So now I can see that for the line to be a tangent to the circle, this condition must be satisfied. So now I can see that here in this quadratic equation, that the coefficient b is represented by this, the coefficient a is represented by this 2, then the coefficient for small c here is represented as that. So plug those in, and this is what I'll have. So simplify this further, and I'll be left with negative 4c squared plus 16c being equal to 0. So now I can actually factorize out a negative 4. So when I factorize that out, I'll be left with c minus 4 in the brackets, of which either negative 4c is equal to 0 or c minus 4 is equal to 0. So c can either be 0 or c can either be positive 4, and those are the values of c that can make this line a tangent to the circle. Alright, so moving on to question 7. So I've been told to show that part of the line 3y is equal to x plus 5 is the chord of the circle x squared plus y squared minus 6x minus 2y minus 15 is equal to 0, and hence find the length of this chord. Now in this case, we've been told to find the chord of the circle. So remember that that chord is actually a line that actually cuts through the circle in a way. So now we'll have it as 3y being equal to x plus 5. That's the line. Now we can actually make y the subject, and y shall be equal to x plus 5 over 3. So we're going to substitute for y into the equation of the circle, and this is what I'll have. So when I expand this value here, I'll be left with x plus 5 squared over 9 minus 6x minus 2. Then when I expand this, I'll have, chase doesn't need to be expanded, so it remains as it is. Then right further, I can find the LCM. So now when I look at the 9 and the 3, the LCM shall be 9. And then at the top, this is what I'll now have. So when I cross multiply, this will become 0 at the numerator, and then at the denominator, and then I'll have only the top value remaining. So next I can expand this value here, then open brackets here, and this is what I'll have. So when I simplify this further, I'll have 10x squared minus 50x minus 140 is equal to 0. So I can also set I can divide all by 10, and I'll have the quadratic equation as x squared minus 5x minus 14 is equal to 0. So now in this form, I can now remember that for the line to intersect or be a chord of the circle, b squared minus 4ac should be greater than 0. So now we're going to prove that it's actually greater than 0. So now we'll have 25 plus 56, of which I'll have 81, and 81 is greater than 0. So therefore the line is the chord of the circle. Alright, so for the next part, we've been told to find the length of this chord. And how do we do that? So now we'll look back at the quadratic equation that we had found, and we're going to solve it and find the values of x. And then for each point of x, we shall find the value of y. Alright, so to find the length of the chord, we'll solve this quadratically, and we'll have x as either being equal to -2 or x being equal to 7. So now when x is -2, y shall be equal to 1. And then when x is 7, y shall be equal to 4. So now that I know that, I can see that the 2 points of the chord shall be, let's label one point A. A shall be -2, 1, and then the other point of the chord shall be 7, 4. So now I can find the length of this chord from this method. So the length of this chord shall be found from here. So now I'll have it this way. Now you can say that 7 minus -2 shall be the same as 7 plus 2. Then 4 minus 1 is that way. So now 7 plus 2 is 9. 9 squared is 81. 4 minus 1 is 3, of which 3 squared is 9. So 81 plus 9 is 90. So AB is root of 90 units. So therefore the length of this chord is root of 90 units, and that is the answer. Right, so the next part, we're going to learn how to obtain the equation of a circle given a point and the tangent to the circle. So now this is an example where we're given a point. So the point is B, for example, and then the tangent is given. So the tangent is given as that. So now we can see the tangent touching the circle at point A. And then you see the radius of the tangent makes an angle of 90 degrees with the circle. Alright, so to find the equation of a circle, when you're given the equation of the tangent line and the point A, x naught, y naught, where the tangent touches the circle, and another point on the circle, B, x1, y1, you can follow these steps. So actually what it means is, in this case, we don't know the equation of a circle, and also that means we don't know the values or the coordinates of the center. So we only know the equation of the tangent, we only know the point AB where the tangent touches the circle, and we know another point B which also lies on the circle. So how will we find the equation of a circle? So these are the steps we follow. So first of all, you have to find the slope of the tangent line. So the equation of the tangent is usually given in the form y is equal to mx plus c, where m1 is the slope or gradient of the tangent line. So if you have the equation of the tangent line, you already have the value of m1. And then next, to find the gradient of the perpendicular radius, that is the next step. So since the radius of a circle is perpendicular to the tangent line at the point of tangency, you can find the gradient of the perpendicular radius m2 by taking the negative reciprocal of the slope of the tangent line. So remember that the gradient of the tangent times the gradient of the radius is -1. So that means we'll have m1 times m2 being equal to -1, of which m2, which is the gradient of the radius, shall be -1 over m1. And then next, use the point slope form to find the equation of the radius. So using the point slope form with the gradient m2, you can find the equation of the radius from this formula. Then next, find the center of the circle. So the center of the circle will be at the intersection point of the radius and the tangent line. You can do this by setting the equations of the radius and tangent line equal to each other and solving for the coordinates a, b of the center. And then next, find the radius of the circle. So once you have the center, you can find the radius by calculating the distance between the center and the point A, x0, y0, which is given in the problem. You can use the distance formula given here. And then lastly, write the equation of the circle. So using the center AB and the radius r, you can write the equation of the circle in standard form. Now this will make sense as we look at different examples. Example 1. Find the equation of a circle which touches the line 4x plus 3y minus 12 is equal to 0 at the point 3, 0 and passes through a point -1, -3. So when someone looks at this, it actually looks complex because it looks like there is a lot to discover. We don't have a radius, we don't have a center. How do we find the equation of a circle? So we should just follow the steps. So first of all, let's sketch this. So this is what we actually have. Alright, now I'm going to first find the gradient of the tangent. Now I know the equation of the tangent. Now I'm going to rearrange it. Alright, so when I make y the subject, y shall be equal to -4/3x plus 12/3. And then 12/3 shall give me 4. So I can say that the gradient of the tangent m1 is -4/3. So that means that now I can now find the gradient of the line SC, which is here. So m2, which is the gradient of the radius, shall be found from this formula. So m2 shall be equal to -1/m1, which is the same as -1/-4/3, of which I'll have m2 being equal to 3/4. Alright, so now we can say the gradient of the radius SC, which is m2, shall be equal to 3/4. Alright, so next I'm actually going to form two different equations. So what I'm going to do is I'm going to form an equation for this line. Now this line, I can see it's from point A, which is known to the point C. So I'm going to form two different equations using this line and this line, because I can see that this is radius and this is radius. So I can already see that to form an equation for this line, since I already know the gradient, I can see that b minus 0 over a minus 3 shall be equal to the gradient that I've already found here. Then I can also form an equation using this line BC. So let's see what I mean. So now for that line SC, I can already see that b minus 0 over a minus 3 for that line shall be equal to 3/4, because I know the gradient of that line, of which I can see that 4b shall be equal to 3a minus 9, and then I'll have the first equation, 3a minus 4b is equal to 9. So that is an equation that I actually form from the gradient, from knowing the gradient of that line AC, while just looking at it as a line. Then next, I can also see that the distance SC is also equal to the distance BC, which is equal to R. So I'm actually going to use the knowledge of distance to actually solve for BC. So I think it is very clear that this distance here is equal to R and this distance here is also equal to R. So how do we solve for distance BC? Now since the distance SC and the distance BC are both equal to R, let's solve for it. So we're going to equate both the distances of both of the sides. Now we're going to use that to form another equation. Now we can see that SC, which is going to be equal to a minus 3 squared plus b minus 0 squared, and then BC shall be a minus -1 squared plus b minus -1 squared. So that's what I have on this side. So now I'll solve this further, and this is what I have. So next I'll square both sides to remove the roots, and then this is what I'll have. So expand this, and then I'll be left with -6a plus 9 being equal to 2a plus 1 plus 6b plus 9. As you can see, we had to cancel out the a squared and the b squared because they would cancel on both sides, so that's why we're left with this, and then we'll be left with an equation 8a plus 6b is equal to -1, and that shall be equation 2. So now we have these two different equations that are both true, so we can solve these with the knowledge of simultaneous equations and find the coordinates of the values a and b for the center. So now making a the subject in equation 1, I can see that 3a minus b shall be equal to 9, and then a shall actually be equal to 9 over 3 plus 4 over 3b, of which a shall be equal to 3 plus 4 over 3b. Alright, so substituting for a into equation 2, I will have it happening this way. So now solve this further, multiply the 8 in, and I'll have 24 plus 32 over 3b plus 6b, of which simplify this further, and I'll have 32 over 3b plus 6b will give me 50 over 3b. Now when I make b the subject, b shall be equal to -75 over 50, of which b shall be equal to -3 over 2. So now that I know the value of b, I can solve for a. Now a shall be equal to 3 minus 2, of which a shall be equal to 1. So now I know the coordinates of the center. So the coordinates of the center, a shall be 1 and b shall be equal to -3 over 2. Now next I can find the radius from AC. Now remember that we had said that R is equal to AC, which is equal to that. So now that I know the values of A and B, I can substitute it inside there, and then I will have it this way. So simplify further, 2 squared shall give me 4, and -3 over 2 squared shall give me 9 over 4. So now I can say the radius shall be root of 25 over 4, which shall give me 5 over 2 units. So that is the value of the radius. So now knowing the radius, I can now from general equation of a circle solve for this. So now I'll have it this way. Alright, so next I'm going to expand this. So when I expand it, I'll have x squared minus 2x plus 1 plus y squared plus 3y plus 9 over 4 being equal to 25 over 4. So next I collect some terms together. So now I'll have 1 plus this 9 over 4, then bring this to this side and have it as a negative. And then all shall be equating to 0. So now when I subtract 9 over 4 minus 25 over 4, I'll have a negative 4. So 1 minus 4 shall give me negative 3. And therefore the equation of the circle is x squared plus y squared minus 2x plus 3y minus 3 being equal to 0. And that is the answer. Question 2. Find the equation of a circle which passes through a point 5,3 and touches the line y is equal to, and touches the line 3x minus 4y is equal to 3 at the point negative 2, 4. So this is the same thing. So now I'm going to sketch this also. So now that is the point on the circle, and then the center is CAB, and then that is how we connect them. So first of all, I'm going to again find the gradient of the tangent. So now I'm going to make y the subject and y shall be equal to this. So now from here I can say the gradient of the tangent m1 shall be equal to 3 over 4. Then the gradient of the line radius, remember we can find it from this knowledge that m1 times m2 is equal to negative 1. So make m2 the subject and m2 shall be equal to negative 1 over m1. So we can eventually see that m2 shall be equal to negative 4 over 3. Alright, so next I can now find the gradient of the, now that I know the gradient. Alright, so next, now that I know the gradient of the radius SC, that it is equal to negative 4 over 3, I can now solve for that line. Now I can see that on that line, b minus 4 over a minus negative 2 is equal to that negative 4 over 3, of which this is what I'll have. So when I cross multiply, I will find the equation 4a plus 3b being equal to 4, and that shall be called equation 1. Now we can also see that it is also true that the distance SC is equal to BC is equal to R. So now we shall equate the distance of SC to the equation to the distance BC to find another equation that we shall solve simultaneously with this one. So now what I'll have is this. So now if I square both sides, I'll have a squared, a plus 2 squared plus b minus 4 squared being equal to a minus 5 squared plus b minus 3 squared. So when I expand each one, this is what I'll have. So next I can set a squared and b squared values cancel, and then this is what I'll be left with. Now 16 plus 4 is 20. Then here I can see that 25 plus 9 is 34. So now I'll have 14a minus 2b being equal to 14. Divide all by 2 and I'll have 7a minus b being equal to 7, and that shall be equation 2. Alright, so I'll make b the subject in equation 2, and then b shall actually be equal to 7a minus 7. Now substituting for b in equation 1, I'll have it this way. So I'll have 4a plus 21a minus 21 being equal to 4, of which 25a shall be equal to 25 and a shall be 1. So now I can solve for b also, and b shall be equal to 0. So these are the coordinates of the center, 1, 0. So now that I know those, I can find the radius from finding the distance SC. So now remember that SC shall be given from this equation. So now plug in the values of a and b, and I'll have it as root of 3 squared plus negative 4 squared, and I'll have it as root of 25, of which radius shall be 5 units. So now that I know the radius and I know the coordinates of a and b, I can now use the general equation of a circle to solve for the equation of the circle. So plug those in, and this is what I'll have. So now I have x squared minus 2x plus 1 being equal to y squared is equal to 25. So now arrange this, and I'll have the equation of the circle being equal to x squared plus y squared minus 2x minus 24 being equal to 0. So therefore the equation of the circle is x squared plus y squared minus 2x minus 24 is equal to 0. And that is the answer they wanted. Alright, so next we'll look at how to obtain the equation of a circle given the center and the tangent to the circle. So this is different. So now we don't know the point at which the tangent touches the circle, but we now know the center. So now this is what we have. So R is there, and then the equation of the tangent is given, and then the center is known. So when the center is given, the radius is now the perpendicular distance of the center of the circle from the point the tangent touches the circle. Now, if you know the equation of the tangent and you know the coordinates of the center, there is actually a formula we can use to find the radius. To simplify this quickly, so you can find the radius from the formula below when the point at which the tangent meets the circle is not known. So now this is how we'll find the radius: ax plus by plus c over root of a squared plus b squared. So this will give us the radius, where a, b, c are the coefficients from the equation of the tangent, and x and y are the coordinates of the center. So we shall be representing the coordinates of the center right now as x and y. Let's look at an example. So being told that if the line 3x minus 4y minus 12 is equal to 0 is a tangent to the circle whose center is 1, 1, find the equation of the circle. Right, so this is the circle. So the center is known, and then that is the tangent. So now we can find the radius first. Remember that once we know the radius, we can already find the equation of the circle because we already know the coordinates of the center. So now in this case, we're going to just quickly find the radius. So the equation of the tangent is given this way. Now remember, for us to use this formula, the equation of the tangent should be arranged in the form x first, y second, and then the other value, and then we shall equate that to 0. So you can see that a shall be 3, b shall be negative 4, and c shall be negative 12. So now to find the radius of this circle, we're going to use this formula. So remember, we can see that a is 3. Now remember that x and y represent the coordinates of the center, so that is 1, 1. And then when we simplify this further, I'll have it as 3 minus 4 minus 12 over root of 9 plus 16, of which I have negative 13 over root of 25. But remember that in this case, we shall ignore the negative sign. So I'll have it as 13 over 5 units for the radius. So now that I know the radius, I can find the equation of the circle. So plug those in and I'll have it this way. So rearrange this even further. Then I can actually bring this to this side and I'll have it as this. So therefore the equation of the circle is x squared plus y squared minus 2x minus 2y minus 119 over 25 being equal to 0. And that's how we work out such numbers. In question 2, we're being told to find the equation of the circle which has its center on the point 1, 2 and touches the line x minus 2y is equal to 7. So this is the same thing. So we know the center and we know the equation of the tangent. So now we can just simply find the radius. So now the equation of the tangent has to be arranged in the order xy and then the c. So we'll have it as x minus 2y minus 7 being equal to 0. So you can now see that a, the coefficient of x shall be 1, the coefficient of y is negative 2, and the coefficient at c is negative 7. So now we can find the radius of the circle. So remember, this x and y here represent the coordinates of the center. So now this is what I'll have. Simplify that further and I'll have it as negative 10 over root of 5. Now we can ignore the negative and I'll have r being equal to 10 over root of 5 units. So from the general equation of the circle, I can now find the equation of the circle. So plug those in and I'll have it this way. So this squared shall give me 100 over 5. Then expand the values on the left hand side and this is what I'll have. So now 100 over 5 is 20. So that's why I have a 20 right there. So now rearrange them and I'll have the equation of the circle being equal to x squared plus y squared minus 2x minus 4y minus 15 being equal to 0. So therefore that shall be the equation of the circle. Question 3. Find the equation of a circle whose center is at the point 5, 4, which touches the line joining the plane 0, 5 and 4, 1. So this is a unique example. It's just that we've been given the line of the tangent, but we've not been given the equation of the tangent. We've just been told 2 points that the tangent line connects to. So now this is also an easy one. So we're going to first find that equation of the tangent. So now we can first find the gradient of this line right here before we find the gradient of this, the equation of this line of the tangent. So now the gradient shall be 1 minus 5 over 4 minus 0, of which m shall be equal to negative 4 over 4, which is negative 1. So we know the gradient of the tangent line now. So now let's find the equation of the tangent line. So it shall be found from this formula, of which I'll have y minus 1 be equal to negative x plus 4. So I'll have it as x plus y minus 5 being equal to 0. So this is now the equation of the tangent line. So now that I know that, I can now solve this further. So now I can already see that the coefficient at x is 1, that shall be a, the coefficient at y is 1, and that shall be the b, and the coefficient at the next part is -5, so that shall be the c. So now to find the radius of this circle, I'll use the formula. But remember the x and y coordinates here, the x and y values here are representing the coordinates of the center of the circle. So a is this, b is that, and c is that. So solve that further, and I'll have this. I have 4 over root of 2, and that shall be the value of the radius. So now from the general equation of a circle, I'm going to plug in the values. So now this a here is representing the center, and this represents the center also, so remember that. So now plug this in, and I'll have this. So when I expand, 16 divided by 2 is 8. So now rearrange this, and I'll have the equation of a circle being x squared plus y squared minus 10x minus 8y plus 33 being equal to 0, and that shall be the equation of the circle. Alright, so the next one is a question from UNEB 2017, and this was question 10. So I'm being told that a circle whose center is in the first quadrant touches both the x and y axes, and the line 8x minus 15y being equal to 120. So part A, find the equation of the circle, and part B, find the point at which the circle touches the x axis. We're going to first find the intercepts of the line. So we shall look at it this way. So from this equation of the line, when y is equal to 0, we can see that x shall be equal to 15, and then when x is equal to 0, we shall see that y is equal to -8. So therefore the intercepts are 15, 0, and 0, -8. So that's are going to be the first points we shall plot. So we're going to first place those intercepts. So that's going to be the first one, and that is going to be the next one. Then we're going to draw the line through that. So now we've drawn the line, we can actually now place the circle. So we've been told that the circle is in the first quadrant and touches both the x and y axes, and the line 8x minus 15y being equal to 120. So we're going to place the line right there. So the line touches this line, it touches the line, it touches both the x and y axes, as you can see, and it is in the first quadrant. So when it comes to a circle, we should just have to remember that when a circle touches both the x and y axes, it means that the coordinates of the center are both equal to radius. So both of them are going to be equal to r, and that shall be our diagram. So now that we know that, we can actually now solve and find the equation of the circle. Alright, so first of all, before I find the equation of the circle, I can already see that all I have to do is find the radius. Since the coordinates of the center are both equal to radius, it means I just need to quickly find the radius. But now that I know the equation of the tangent, I can use the formula of radius to actually find the radius value. So now to find the equation of the radius, I can remember that from this equation of the tangent, it's already arranged as xy. So now I can actually see that a shall be 8, b shall be -15, and c shall be -120. So to find the radius of the circle, I'm going to plug in the formula. So now you can see that where there is x here, x represents the coordinates of the center. So I'm going to place r, then here it's also going to be equal to r. So r is going to be equal to that. So solve this further, and I'll have 8r minus 15r shall give me -7r minus 120 over root of 289, which is equal to 17. So the next step I can see is I can actually rearrange this differently. So I can actually pull out a -1, of which, remember, in this case the -1 is meaningless, so it should actually be cancelled. So I remain with 7r plus 120 over 17. Cross multiply, this is what I'll have. 17 minus r shall be equal to 10r, all being equal to 120, and r shall be equal to 12 units. So now that I know the value of r, it means that I know the coordinates of the center. So the coordinates of the center are now c, 12, 12. Now from the general equation of a circle, now I'll actually plug all these in, and this is what I'll have. So x squared minus 24x plus 144 plus y squared minus 24y plus 144 shall be equal to 144. So simplify this further, and I'll have the equation of the circle as being x squared plus y minus 24x minus 24y plus 144 is equal to 0, and that shall be the equation of the circle. And then in part B, we're being told to find the point at which the circle touches the x-axis. That means we're interested in this point right here. So as you can see at this point right here, the value of y is actually equal to 0. So that simply means we can just go into the equation of the circle, and actually wherever there is y, we just make it 0 and we'll get the value of x. Alright, since we know the equation of the circle, we can remember that at the point the circle touches the x-axis, y is 0. So now wherever there is y, we're going to place a 0. And then this is what I'll have. So simplify this and I'll have this quadratic equation. So when I solve this quadratic equation, and what I'll find is I'll find that x shall actually be equal to 12. So therefore, at the point at which the circle touches the x-axis, x is equal to 12, and that is the answer. Alright, so let's move on to the next question. So being told that a circle has the equation x squared plus y squared minus 2x minus 4y minus 4 is equal to 0. Find the equations of the tangents which are: part A, parallel to line 3x minus 4y minus 1 is equal to 0, and part B, perpendicular to the line 3x minus 4y minus 1 is equal to 0. So how do we solve this? Alright, so now the first step shall be to find the equation of the tangent in this case. Now, as you can see, we've been told that the equations of the tangent, so that means that there are actually two tangents touching this circle, and then those two tangents in part, both of them are parallel to this line here. So that means that first of all, we can actually identify the gradient of those tangents. So since they are parallel to the line 3x minus 4y minus 1 is equal to 0, it means that they share the same gradient. So now let's make y the subject here and then find the gradient. So we shall have it as 3 over 4x minus 1 over 4. So since the tangent is parallel to this line, it means that they have the same gradient. And then the gradient of tangent m1 shall be equal to 3 over 4. So now we can see that the equation of the tangents are usually in the form y is equal to mx plus c. So therefore, that means that the tangents shall be in this form, the form y is equal to 3x plus c. Now in this case, there shall be two different equations of the tangents, but we don't know what they are. But this is how they shall actually be arranged. So now the equation of the tangents here is actually incomplete because we don't know the value of c, and that is what we shall be looking for. So now let's actually put this back in the form where it actually looks the same as that. So now I know the gradient of the tangent. So now I'll have it as 4y being equal to 3x plus c, of which eventually I'll have it as 3x minus 4y plus 4c is equal to 0, and that shall be equation 1. So to find those two equations of the tangents, I shall now just have to find the values of c. Now, next step shall be to find the center and radius of the circle. So now the equation of the circle was given. So now if I compare this to the Cartesian equation of a circle, I can see that 2g shall be equal to negative 2, of which g is negative 1, and 2f shall be equal to negative 4, of which f shall be equal to negative 2. So therefore the center of the circle, which is negative g negative f, shall be 1 and 2. Then I can also now find the radius of this circle. So the radius shall be equal to root of 1 plus 4 plus 4, and that shall be root of 9, of which r shall be 3 units. So now that I know that, I can now first sketch what is happening. So now I can see that we have the circle, then we have a line. The line is 3x minus 4y minus 1. Then we're being told that the two tangents to this circle are parallel to that line, so we draw them parallel. And now we've identified that the center of this circle is 1, 2, and then now we have two possibilities for the equations of the tangents, but they shall all be in this format. So what shall differentiate these two equations of the tangents shall be the values of c that will be different. So this is what I have. So I know the values of the radius 3 and 3. So now we shall use the formula of finding radius of a circle given center and equation of tangent and solve for c. So now we know that another formula that we can use to actually find the radius of a circle when we know the center and when we know the values of the radius. I mean the values of the equations of the tangents. And then we shall use those to solve for c. So remember this formula. So when we look at this general equation of the tangents that we actually have, we can actually see that the a value is 3, the b value shall be equal to negative 4, and this c value shall actually be equal to this whole 4c. So that's what we have right now. So plug those in and this is what I'll have. but remember the center coordinates are the x and y shall be 1 and 2. So simplify this further, and I'll have negative 5 plus 4c over 5. And then I can actually pull out a negative, and I'll have negative into 5 minus 4c. Now in this case, since we have this modular signs here that actually eliminate a negative and a positive, it actually means that there are two ways of representing this equation. So since the negatives do not matter, it means that this equation can be represented as either 3 is equal to 5 minus 4c over 5, or negative into 5 minus 4c over 5. So both of these cases are true because they are all inside a modular sign anyway. So for the first case, we'll have it this way as given here. So now when we cross multiply, I have 15 being equal to 5 minus 4c. Then 15 minus 5 shall be equal to negative 4c, of which c shall be equal to negative 10 over 4. And then simplify this, and I have it as negative 5 over 2. So now that I have this, I can now first substitute this into equation 1 and find the first equation of the tangent line. So substitute that in, and I'll have the first equation of the tangent line shall be 3x minus 4y minus 10 being equal to 0. So that is the equation, one of the equations of the tangent. So let's find the other equation using this other second case. So for the second case, this is what I have: cross multiply, and I'll have this. Now first of all, when I take this negative back in, and I'll have negative 5 plus 4c. So cross multiply, and I have 15 being equal to negative 5 plus 4c. So this shall give me 20 being equal to 4c, and c shall be equal to 5. So therefore, now again, when I substitute for this into equation 1, I'll have 3x minus 4y plus 4 times 5, which shall be 3x minus 4y plus 20. And this shall be the second equation of the tangent. So therefore, the equations of the tangents parallel to the line 3x minus 4y minus 1 is equal to 0 are 3x minus 4y minus 10 is equal to 0, and 3x minus 4y plus 20 is equal to 0. And those are the answers. Alright, so in part B, we're being told to find the equations of the tangents which are perpendicular to the line 3x minus 4y minus 1 is equal to 0. So we're going to follow the same process, but now here we're looking at the tangents which are perpendicular to this line. Alright, so now we're going to find the equations of the tangents. Let's find a general form of expressing those equations of the tangents. So now we've been told that they're perpendicular to this line. Let's first make y the subject in this line and get the gradient. So now we can see that its gradient is 3 over 4. Now since the tangent is perpendicular or perpendicular gradient of this line m2, so you can see that m1 times m2 shall be equal to negative 1. So we shall find the gradient of the tangent as being equal to negative 1 over this 3 over 4. So I'll have it as negative 4 over 3. So these shall be the gradients of the tangents. So the equations of the tangents, remember, are always written in the form y is equal to mx plus c. So that means that our equations of the tangents which are perpendicular to this line shall be in the form negative 4 over 3x plus c. So now that we've put the gradient in of the tangents, let's rearrange these into this format. So I have it as negative 4x minus 3y plus 3c being equal to 0. So now all I have to do is solve for c, and I shall actually find those two equations of the tangents. Alright, so in this case, we don't need to solve for the center and the radius because we already know them, we already found them. So let's sketch this. So we have our circle, the center is 1, 2, and then we can see that this shall be the tangent. So there are two tangents and they're perpendicular to that line. So that's how we draw perpendicular lines. So they all make an angle of 90 degrees with this line. So these are the two formats of the ways you can represent the equations of these tangents. So we can see that they all make an angle of 90 degrees with the radius, which is 3. So again, we shall use the formula of finding the radius of a circle given the center and the equation of tangent and solve for c. So this is the formula that we shall use. So when you look at this format here, now what you may have asked yourself is, why do I always put my equation of the tangent back into this form? It is because it is in this format that I can easily use this formula. So take note of that. So now I can see that the value of a shall be negative 4, b shall be negative 3, and c shall be positive 3, c. And then x and y represent the coordinates of the center. So this is what I have. So put those in, and I'll have it this way. Simplify further, and I'll be left with negative 10 plus 3c over 5. So next, pull out a negative, and then this is what I'll have. So I can already say that since we have modulus outside, it simply means that this can actually be represented in two different ways, whether there is a negative or whether there is none. So either we can have the case where there is no negative, and we can have the case where there is a negative, and both cases are true. Alright, so now for first case, this is what we have: cross multiply, and I have 15 being equal to 10 minus 3c. So solve for c, and c shall be equal to negative 5 over 3. So when c is negative 5 over 3, I'm going to substitute for it into equation 2, and then this is what I'll have. So I'll get the answer as this. So I'll be left with negative 4x minus 3y minus 5 is equal to 0, but I cannot take all this to the other side of the equal sign, and I'll have them as 4x plus 3y plus 5 being equal to 0, and that shall be the equation of the first tangent line. Now let's solve for the second case. So for the second case, this is what I'll have. Now first take this negative inside, and I'll have negative 10 plus 3c cross multiply, and I'll have 15 be equal to negative 10 plus 3c. So 25 shall be equal to 3c, of which c shall be equal to 25 over 3. So substitute for c in equation 2, and I'll have it this way. So I have negative 4x minus 3y plus 25 being equal to 0. So when I take all to again this other side of the equal sign, I'll have 4x plus 3y minus 25 being equal to 0. And that shall be the second equation of the tangent. So therefore, the equations of the tangents perpendicular to the line 3x minus 4y minus 1 is equal to 0 are 4x plus 3y plus 5 is equal to 0, and 4x plus 3y minus 25 is equal to 0. Alright, so this has been a long ride with tangents. So next, I have an exercise for you. I encourage you to try out these numbers and then get better. So compare your answers to the answers that I've actually listed in brown color for you to make sure that you're actually on the right track. So this is question 1 to question 7. So the questions continue. So this is question 8, 9. This is question 9. Those are the answers. Question 10. Question 11 with its answers given there. So questions continue. Question 12. Question 13. Question 14. Question 15. And lastly, question 16. So try these out and get better at your knowledge of tangents and normals to a circle. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If it did, feel free to share the video with all your friends and help as many as you can. And then if you really like the video, feel free to give the video a like or a thumbs up, and then tell me in the comments if the video really helped you, and I'll try to get time and reply to your comments. And then if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Thank you so much for watching, and I'll see you in my next video.